Welcome everyone to another afternoon of the CERIAS Security Seminar. As a reminder on procedure, please don't enter any questions into the chat. If you have questions for the speaker, please put them in the Q&A, which should appear at the bottom of your screen. And at the end of the talk, he will respond to questions as time and circumstances permit. With that said, let me introduce our speaker, Dr. Jonathan Spring. He has a bio on the webpage for the seminar, but in brief, he has a background where he worked at the CERT and CEI and SEI at Carnegie Mellon, and then transitioned into a role at the CISA, which is part of DHS, the Cybersecurity and Infrastructure Security Agency at DHS. And he's going to talk to us today about security operations for AI systems. And so thank you very much for being here, Dr. Spring, and please take it away.
Thank you, Spaff. Honored to be here. Thank you, everyone, for listening, coming. If there are questions for clarification, I would prefer if you can put them in the Q&A, and I'll try to make sure that I can clarify anything as we're going. I don't want to lose anyone as we're going. There's going to be, there's a lot to cover here. Try to make it concrete, but also give all the context. We've been doing a lot of work on AI systems recently within CISA, and of course, CISA's mission is all about security operations. I have history with both network forensics and vulnerability management, so I'm going to bring some of those into context or into the conversation to sort of go into a little bit more detail as examples, but those are certainly not the only examples. Also, you'll probably notice a little bit, because of my history more on the security side of things, I have 5 years of experience working with AI developers and AI systems and AI policy stuff, but I'm not as an experienced an AI engineer as I am on the security operations side. So I think that shows a little bit, and also that about ability to converse and to interact and to do that sort of translation is like part of what I want to talk about today and what we need for that. So a little bit about the current state of affairs for background on security operations. First is the form of incident response and security teams. This is a quote from the CCERT services framework. A CCERT is a computer security incident response team, right? So security operations, they're support a constituency for either preventing, detecting, handling, or responding to incidents. Incidents very broadly are violations of an organization's security policy, right? So we have to get into defining what security policy is. Of course, that can be an access control policy, right? That can be other kinds of policies about authorization, right? But that's the general context. There's, other slightly different definitions of this, enterprise security strategy, right? So strategy a little bit higher level, that's going to be talking about like C-suite folks, like there are commonly chief information security officers now, right? So processes, technology, and people, this is obviously important. You can't have anything without all three of those working together. Security posture is like a risk management aspect, right? Risk management posture. Right? We can also put security operations into the context and frame of broader business continuity planning or continuity of operations. That was a review that I did in 2021, specifically about incident analysis standards and decision-making. Incident analysis, some part of security operations. There's other parts like vulnerability management, situational awareness, event management, like all of these things. There's pretty established government processes. CISA is many thousand people. Some of it is for critical infrastructure. A lot of it is for cybersecurity. We lead this whole national effort to understand, manage, and reduce risk to the cyber and physical infrastructure. I think that having a whole agency dedicated to something like this tells you a bit about the level of government process. There's lots of different details. CISA is in many functionalities, a national CSERT. We participate in first, we coordinate with other national governments and their national CSERTs on matters of interest and collaboration. We help support the community within the US and nationally for functioning vulnerability management ecosystem, like these sorts of things. There are also, policies about how both the country and the federal government itself interacts with information security operations. Parts of that specific executive order, which is what EO stands for. I mean, if you Google EO 14028, you will find the text of the executive order. But it includes things like when the government purchases software, there has to be an asset list in the form of a software bill of materials for what the components of the software are. That helps with vulnerability management, asset management. It helps with incident analysis, so you know what aspects of the software might have been compromised or what vulnerabilities there were in the software. Right? It includes that software should have a vulnerability management and update management process so that you can get patches from the developer when there is a problem. The Office of Management and Budget circular there relates to things like the Federal Information Security Management Act, FISMA. I might have that acronym wrong. Anyway, lots of acronyms in this space, obviously. It's also where we get things like FedRAMP for authorization of the security policies and security postures that have to be in place for cloud services in order for the government to purchase them, these sorts of things. The point of this is not to say, that we're going to cover all of these things in detail, but just that there is like a pretty big and well-developed sense of information security operations in these spaces. Of course, a lot of the initial security research for information security stuff, goes back to even like the Rainbow publications, the Orange Book in the 1980s, 1970s. One of the things this means in the current state of affairs, there are not just dedicated job roles, but there are dedicated departments within organizations for information security, right? There are security operations centers. There are product security incident response teams within organizations. The PCERT's whole departmental or team role is to interface between the software developers and the security researchers finding vulnerabilities, but also to interface between the software developers and the people who need to apply software updates and patches. One of the other things that I do is I participate in the Common Vulnerability Scoring System, SIG at first. So that is one of the ways that people say structure communication about the severity of vulnerabilities in patches, right, is with that CVSS score. There are whole professional societies for information security, right? So SACA, there's all the SANS institutes. In some ways, the various academic publishers are also professional societies. So WC3, ACM, right? All of these places are places where professionals get together to talk about the details of security operations, vulnerability management, incident detection, how these things interface with other parts of the world. You know this well, right? Of course, CERIAS being one of the most prestigious, right? Their whole academic centers around information security, asset management, courses within other departments or within other schools that give people an intro to it, like all of these things. When you have the whole dedicated centers and courses within the centers and degree programs, you of course develop a dedicated way of talking about the topic, a way of conversing with your fellow specialists to convey important information, to get into details that you need special words for, special concepts for, special tools for, special programs for. We have whole tool suites that are for testing security properties of software. And those can be very different depending on what kinds of software we're testing. So let's talk, special interest groups, or you might have people who are interested just in secure coding, and maybe they're just interested in secure programming language development, specialized conferences for anti-abuse for preventing abusive email messages from reaching their recipients, right? So, unsolicited bulk email, commonly referred to as spam, phishing, right? There are whole conferences of hundreds of people where people get together as representatives of organizations, governments, whatever interest groups to talk about how they can collectively address that problem. And that's just like one example within like many dozens of examples for specialized conferences around information security. And then we have the more general conferences, RSA, Black Hat, whatever, where there's like really big tent where everyone sort of comes together and shares the most important outputs from those sub-communities. Especially with information security, we have curated trust groups. Some things need to be private. That's like the whole aspect of security, right? If the adversaries know everything that you're doing, it does make it a lot harder to provide security services. Kirchhoff's principle notwithstanding, there are some things where it is valuable to keep certain things private. Now, on the other side, current state for AI engineering. One way of thinking about this is just developing tools that apply AI to things. The whole AI engineering term has sort of been developed by the SEI, but lots of people are holding it. There are posts at tech companies for AI engineers as a job role. Those job roles are specific dedicated job roles that require specific combined expertise that is not just software development. It's focused on data science and data engineering in combination with those things. They have whole career tracks for those job roles. They have requirements. They have ways that those people can progress in their organization, right? Developing that workforce is a key concern for lots of people. And that is a dedicated specialized workforce that is distinct from other workforces in software engineering or otherwise. When I was looking for background for this talk, I found this very lovely quote, which if I didn't tell you it was from 1974, I think you probably could have placed this as being current. What I'm trying to do here is say that I'm not in this talk trying to talk about all of the possible uses that people have used for the term artificial intelligence since the 50s. I'm aware of them. We can't, I think, have a productive conversation about this with trying to hold all of them, because then that starts to just devolve into things computers can do. So we're going to talk a little bit more narrowly about modern AI systems being not just statistical learning, right? But a lot, we're really focused on these deep neural network sort of techniques for AI and machine learning. There's actually a specific government definition of this. So that is the one that we're going to support here. I'm sure people could have lots of interesting conversations about ways that this does or doesn't fit with, say, the 1970s academic definition and like how that's interesting and what that is. I think that's a really interesting path for inquiry, but it's not one that I'm going to try to go down today. There's a separate executive order, different number there, 14110. That is a specific executive order for policies on artificial intelligence. So similar to information security, we have various presidential level policies in the US on artificial intelligence. Also similar, in various information security circles, we have various national, international organizations, events, blah, blah, blah. Last November, we saw the international event, held in Bletchley Park for the AI Safety Summit that saw various world leaders come together to make commitments about AI safety, AI development, these sorts of things. So the professional community for AI engineering also has its own dedicated job roles. There are also whole departments in companies and organizations that do the ML engineering, the ML operations, the ML deployment. Those can actually be slightly separate teams that need to be integrated. You get the idea. There are also whole professional societies, AAAI, so on, right? Where professionals who do AI engineering ML engineering, ML development, right? Get together, talk about their specific problems. This happens in different spaces than in the information security ones. To some extent, from what I understand, ML engineers, AI engineers are still actually regularly conversant, at least with searches or awareness with new papers that are posted to archive for new developments, because the field is developing so fast, and like that is one of the natural places to converse, right? Very different than just other software engineering disciplines, different than information security disciplines, so on. Of course, and you see a parallel here, right? There are specialized whole academic courses, there are whole schools on machine learning engineering, machine learning at universities now. There are whole specialized conferences and interest groups at the same level, or maybe bigger than information security ones, for various ML topics. There are also curated test groups, because in some ways, the data that goes into training these models can be private or sensitive or proprietary. The exact training, but whatever, right? The engineering steps, right, can be a matter of patent or trade secret or whatever. So there's different reasons why things are held in confidence within the AI engineering community, but also there is this notion of holding things in confidence. So that being said, what you may notice is that I don't think that these communities overlap very much, which is fine, because everyone needs to do their own specialized things. The question is, how do we do security operations for software systems that happen to be AI systems when we have relatively little overlap between the professionals who do both of these things? And this is the sort of topic that I'd like to press on a little bit. I'm afraid that, as a bit of a spoiler, I do not have all the answers for how we're going to do this. So partly I'm here to open some questions, areas for research, areas for you all to continue to run with, maybe some pointers at fruitful areas for further study, development, communication, collaboration. I think that we need to get not total overlap here, then there would be no distinction, people wouldn't be doing their own things, that's not the goal. But we need to figure out how we build reliable structures to make sure that people are able to communicate. In some ways, this is still a work in progress for the information security community and software engineering in general. But I think that there is a lot better overlap there. There's more structure, there's more structured communication, which is one of the things I'll talk about with some of the details for, say, vulnerability management. I don't think that there's actually a way to pick between these two. So it's, of course, security operations for ML engineering, but also you need to mix both. Whichever one you come into it from, you'll probably see your home discipline as the core one. I think that's fine. We need translators who can meet in the middle and exchange ideas and do both. I do want to separate sort of the difference between security operations for machine learning systems that are deployed versus developing AI systems that help a security person do their job for all software systems, which is also a totally valid topic, but is not what I'm focusing on here right now. There's also a sort of threat assessment aspect of AI's intersection with security operations, which is that we may see threats or adversaries able to use AI systems to improve their operations for what they're doing. That increases or changes the threat that you might see that you need to prepare for with your security operations, with your threat management, whatever. That's also not the thing that I am planning to discuss for the next 20 minutes. Those are both things that we are thinking about at CISA. So we have attention on all three of those aspects, but I'm going to focus down here a little bit today on how we do a sort of regular cybersecurity mission for an ML-based software system rather than the other two things. I've been talking a little bit about translation, languages, trading zone. This is on purpose. So this concept comes from Peter Gallison from the late 1980s in the history of science. He happened to be studying physics and needed a concept and borrowed it from anthropology. But in general, this is any space where folks come together who have different jargons, different conceptions of what they need to get done, different professional goals, right? they come together into a shared space and they have some sort of partnership where they combine their perspectives and create some sort of new or shared language. Shared language ends up being a very important part of this. You don't need to completely speak exactly the same language as someone in order to effectively trade with them. Trade ideas, trade concepts. The metaphor here comes from actual physical zones in spaces where people spoke different languages and needed to come together to exchange goods for commerce. Whatever languages we speak, right? If someone doesn't speak English and I only speak English, we can still exchange goods or services with like a relatively limited shared language. We can exchange more rich or more diverse ideas or more complicated items or concepts. We have more of a shared language, but the shared language tends to mirror and map and change with like what the needs are. The insight is that this is also true for engineering and scientific disciplines where people need to come together to share concepts and ideas to get their own work done. One of the things that helps you do that is an object that can sit on that boundary or transmit across the boundary or be understood in both communities. Even though it might mean different things to both communities, it can like retain enough of its identity to be a useful trading object, to communicate information, value, these sorts of things. These are both concepts from history and philosophy of science that I think are valuable to our discussion here and help us understand what's going on and how we might improve the communication intentionally between a community like the security operations community and another community that might be interested and have shared interests and perspectives like the ML engineering community. So since my last 5 or 6 years of experience have largely been with vulnerability management, I will talk about that. I could talk for probably 18 hours about vulnerability prioritization by itself and all the ins and outs, but we're not going to do that here. Just as a more general overview for the things that for an information security person fall under vulnerability management. Again, this is the first CERT services framework, relatively similar to the product security incident response team framework, PCERT, PCERT, right? There's folks who discover vulnerabilities. Discover here means there's a piece of software or a deployed system, and there's not known to be a vulnerability in it, and the techniques you use to discover novel and new vulnerabilities. This could be done by the software engineers. This could be done by researchers on source code that will report it to those software engineers. That is often the topic of bug bounties, right? So sometimes organizations will pay third parties to report the vulnerabilities to them rather than to weaponize them or use them or whatever. It could be adversaries who will be doing vulnerability discovery to find 0 days to use them in an attack. That's actually not normally what happens. Normally for discovery, we're talking about either internal or beneficent third parties who are going to report them through the appropriate channels. Vulnerability report is generally the output of vulnerability discovery, right? So here's the problem, whatever. Some of them aren't actually problems. So report intake includes triage. Everyone always has more work to do than they have staff time to do it. So there's whole sub areas, both of professional discourse and academic research, just on prioritization of vulnerability reports for specific kinds of vulnerabilities, not even all vulnerabilities. And so there's a whole thing there, but there's obviously one distinct service and step within this whole space. Analysis is figuring out what the fix is, very broadly, which is a whole complicated ordeal around the intersection of systems engineering, software engineering, right? Change management. Then of course you have to get into like how you package it into a patch and distributing them, which is actually separate even. Oftentimes vulnerabilities affect more than one party, particularly shared software libraries. So if you have a vulnerability in a library, And that library is used by lots of different software developers in their products, and then there's a vulnerability in the library. All of those product owners will have to coordinate. Well, they don't have to, but it's much better for everyone if they coordinate on a fix so that everyone has a chance to integrate the fix into their systems ahead of time, somewhat in private, in coordination, because that reduces the amount of time that most of the systems will be vulnerable to attack to a known vulnerability that does not have a patch available. So that's the goal you're trying to do here. Very happy to talk about the whole multi-party coordinated vulnerability disclosure sort of paradigm, the work we've done on that to sort of visualize and model that and how we understand success, right? All of these things also, again, whole specialized conferences, professional groups on this. The actual disclosure is when the public learns about a problem. This is supposed to be matched with a patch. Sometimes it's not. Often this is also the point at which we need a unique way to describe the vulnerability. If it's a local vulnerability that's like just say a specific server is misconfigured, maybe that won't need to get a name, change these configuration settings. If there is a need to specifically identify the vulnerability, we get what's called a common vulnerability enumeration ID, right, and so on. And then we have the response, so actually fixing a vulnerability. Often this is in two parts, right? So we have to have the people who maintain the software produce a fix, and then the people who deploy the software need to apply the fix. AI engineering has very distinct current state, right? I think folks are trying to move towards more of an ML ops for continuous deployment, continuous integration. That's moving the ML stuff a little bit away from research and more into deployment and continuous management. Given the data requirements and data engineering, ML ops is distinct from DevOps, right? There's different requirements on the engineering environments. So we've already got sort of its own thing there. A lot of folks have focused on adversarial robustness testing. So CleverHan's Art are open source tools that do that. There's whole lists of that. If you look at ML SecOps, that is a list of curated tools on GitHub with a bunch of links. Those tools are available and can run, but I think that they are not necessarily integrated into the development environments all the time, at least not yet. Maybe we're not there. Maybe that's a goal. It's hard to say. I think it is a goal, but like I don't know what the timeline is on that. Some people definitely have it, but I think that's mostly custom. There's also similarly places where people want to collect and report incidents. They don't necessarily mean security incidents in the AI incident database. Specifically, they're focusing on a history of harms to essentially people, real world, which is not the same thing as a security incident. Right? You can have an accidental harm, and that is a very real and important harm, but no security policy of the organization is necessarily violated. There is a very long history that I'm aware of within the information security literature of discussions between the importance of safety versus security, which of course is not to be confused with the program verification literature on safety versus liveness, which are like different kinds of safety. Bruce Schneier has, historically talked some about the various like differences between how you would operate for security analysis versus safety analysis. There's also a great paper on specifically AI safety analysis by Heidi Klump, which you can find on, I think, the Trail of Bits website, which is where she's working now. So there's all these different moving parts for how these things are currently working and how maybe AI safety interfaces with safety engineering in general is different from security engineering. You might notice in looking at, say, the AI discussions around vulnerabilities in AI systems, even just within the cybersecurity community, that there's multiple uses and meanings of the word vulnerability. This is an important term, it comes up often, but that means that there's also sort of overloaded and overlapping set of terms. which sometimes people are aware of all of them, sometimes they're aware of some, right? All of these things. Similarly for incident, I just sort of highlighted how with the AI incident database, incident is used slightly differently there than when we talk about, say, incident reporting for computer security incidents. Not all of those things would be the same. I think that there's also various incident reporting mechanisms. In other disciplines, incident has like a very general meaning. And so for information security, maybe we should try to always clarify that we mean computer security incident, but then that's cumbersome, so we get shortened, but I think that's where some of the different uses come in, people shortening things. Robustness also has a very long-standing use within both especially resilience, robustness and resilience, both have long-standing uses within both the computer security community and the AI community that both go back at least to the late 1980s and mean distinct things, which can cause some confusion if people read it as just one or the other and aren't familiar with both jargon uses of the term. And so I think that when we have situations where we know we're speaking a different language, right? Like we know that I'm speaking English and this other person is not speaking English, then there's less confusion because at least we know what we don't know. I've observed a lot of situations where we have discordance in some ways between the AI engineering community and the security engineering community because we're using the same English word, but it has different jargon meanings, and that is hard for folks to deconflict. So one of the ways that we tried to crosswalk this when we wrote for NSPW 2020, so on managing AI vulnerabilities in ML and AI systems, is the title of that paper. One of the things that's confusing is vulnerability in InfoSec has a bunch of these different meanings, and the metaphors as how they connect to different parts of an AI system are maybe not obvious. So one of the things is that you have an instance of a vulnerable product. This means we're running 1,000 computers. They run some specific operating system version. Installation number 6 is running version 11.2. We know that's vulnerable to some CVE ID. That's an instance of a vulnerable product. It is an instance of the vulnerability, like we can apply a patch or an update to fix that specific computer. That is different than what we mean when we say there's a vulnerability in the operating system version 11.2. Those are the sorts of things that get CVE IDs. All of the instances of a vulnerability should have the same CVE ID. This is true, if there's a shared library, then everything that uses that library should have the same CVE ID. So there'll be instances of that vulnerable product in other pieces of software that then there are instances of that overall, like say, operating system. So this can get sort of recursive and a bit confusing. And then we also have this aspect in which we categorize vulnerabilities together into broader categories, which helps with educating software engineers to not do like buffer overflows, buffer overflow being one of the categories. Use after free, use various sort of broad categories of vulnerabilities. So a CVE can be an instance of a CWE, common weakness enumeration. The E does not stand for the same thing in those two acronyms. Unfortunate that the V and the W look very similar. OWASP also has, categories of vulnerabilities specifically for the web. So we can have a vulnerability in a product that has a specific CVE ID. We have an instance of that product installed on my network. That vulnerability can be a buffer overflow, which is a category of vulnerability. We often use, when we're just talking freely, the word vulnerability for all three of these things, which can make the metaphors with the AI space confusing because exactly how those three things map to an AI system is not straightforward. A vulnerability in a product can also be different kinds of products. So this is like a level of abstraction based on what the product is or where it is in the product. So you might have a configuration level vulnerability. You misconfigured your web server to allow reading what would otherwise be a private directory, which exposes private information, and you need to change the access control on that web server so that that's not exposed. right? That's a specific configuration level vulnerability in a web server. We won't give that sort of a thing a CVE ID, but we might give it a CWE, right? It might be a category of you've allowed access when you shouldn't. So there's that, but then that's not about how the web server code itself was implemented. We could have an implementation level vulnerability in, you're implementing the HTTP protocol, you misread the spec, you implemented it wrong, you put a buffer overflow into a way that it reads off the network. So your version of the web server will have an implementation vulnerability. That'll get a CVE. The people who are operating instances of that web server need to apply a patch, whatever. There's also vulnerabilities that can occur at that protocol and algorithm level. So I mentioned HTTP as a way that you might have misimplemented. That is, of course, a protocol. It is possible for the pen and paper specification of the protocol to have a vulnerability. This has happened a number of times. If that's the case, then everyone who implements the protocol has to re-implement the protocol because the protocol needs to be fixed first, and it needs to be changed in implementation, and then all those patches need to get applied. It's very rare that we have algorithm level vulnerabilities in information security, but it has happened. So for example, the MD5 hashing algorithm in the early 2000s was considered to have a known vulnerability in that the search space could be reduced. So there was no CVE issued because MD5 this happened about the same time as the CVE program was getting started. I don't think they backdated for one. But that sort of thing also in concept would get a CVE ID, and then every protocol that uses the algorithm needs to make that algorithm not valid, and then all the implementations need to change so that they respect the protocol as having the algorithm not be valid, and so on. In general, we see this AI red teaming stuff where people are trying to find problems with deployed generative AI system. And so often this takes the form of, can we make the AI system give a sort of problematic response? Well, how do we conceptualize that in information security terms? Is it a policy violation, like a security policy violation, for the AI system to give an inappropriate response? Doesn't seem like it quite fits. Maybe it's not a security violation at all. It's clearly not a CVE for each specific prompt that produces an unacceptable response, right? That's not a good metaphor. But is the ML system misconfigured, right? Is it like our web server with the wrong access control permissions, where we just need to change some settings and then it won't produce that problematic response anymore? Well, I mean, in some ways, it is a configuration that it gives, a bad response to specific input. And we could actually identify this CWE, which is about essentially gradient descent allows for misclassification, which is a problem like across all gradient descent trained ML systems, right? So we could identify a configuration vulnerability that this allows for this. And there's an instance of this CWE here, which Miter has already published like several years ago about a specific kind of error in an information system. Of course, AI systems are a kind of information system that sort of argues for treating them under the same regime as information security. But of course, we also have to find these prompt injections like very differently than we find lots of other information security problems. Although, adversarial machine learning also sort of looks a little bit like the way that we find program errors using fuzzing. So is prompt injection vulnerability discovery? Like, is it more like fuzzing? Like what lessons would we have if we needed to talk about a cybersecurity red teaming engagement where the team needed to be prepared to, apply fuzzing techniques to find new vulnerabilities in important systems during the red team engagement? Is that like what's going on? Is that how we fit it together? Will that help the folks who conduct pen tests to understand how adversarial machine learning interfaces with what they understand? Will it actually harm will it make it harder for the ML engineers to understand what you're talking about if you use fuzzing, which is a jargon term from information security? Like, what is the general term here that we could use that would let both people understand that's not like sort of overloaded in one community or the other? I'm afraid that, like I said at the beginning, I don't have answers to all of these questions, but I'm opening a lot of doors here that I see potential issues for. When CISA does a red team assessment, which is one of the services we provide to constituents in order to help increase and manage the security posture of the US critical infrastructure, right? We have folks who go and conduct red team assessments at critical infrastructure providers and use those findings to harden those systems in collaboration with the critical infrastructure provider, like invited by them, right? Whole thing is all, as planned and in conversation. The red team emulates a threat actor to assess the whole organization's detection and response capabilities. During the first phase, the red team tries to get in. During the second phase, they attempt to trigger a response from the security team so they can learn about the incident response, what they're able to find, erratically detect, right, how they push the threat actor out. And then there's a whole after action report on both phases, for what can be improved. That's all just taken from that advisory there. That does not look like exactly what AI red team engagement looks like today. But the AI red team engagements are a bit more limited. Maybe the metaphor is with vulnerability assessment, something like this. But it's very much the same in that it is an attempt to emulate a cyber threat actor to assess the system's detection and response capabilities. So how do we learn from that metaphor to make sure that we're staying in step, that everyone sort of can understand how we're assessing and assuring these information systems, whether they're AI or not? What concerns do we have from the AI community and the ML engineering community that can't be applied? Retraining a model that took 6 months to train to remove certain problematic prompts, probably not going to be a viable solution. On the other hand, there's plenty of regular old cybersecurity vulnerabilities in ML deployment pipelines where there's just a buffer overflow in the open source component that manages the model. So obviously we need those kinds of communications also, where the people who deploy and manage ML systems need to understand sort of the more basic cyber hygiene stuff. Whenever we're coordinating an issue, the community is key. The shared trust groups are key. Open source has its own norms than the various private sector folks. I think a lot of folks in different countries have slightly different norms, but the community is the key, and the community sharing the norms and being able to converse is really the key. So having a ML engineering community that is not familiar with the security operations processes is a sort of latent risk as those systems get more embedded and more operational, then the likelihood that we have a moment where the community suddenly realizes that they haven't learned enough about the security operations side of things is a risk that we might want to try to mitigate ahead of time. I'm happy to talk with anyone who might want to interface about that and connect folks with folks who can sort of do some of that outreach. Do encourage anyone from sort of ML engineering folks. A lot of companies that do ML engineering say may have a product security team that is a member of FIRST and participates in that specialized community. But like the PCERT may not talk to the ML engineering component of the company if the company is very large. So, recommend PCERT folks or ML engineering folks to reach out to each other within each organization to build those bridges. For any community or organization that does ML engineering, but is not participating in one of these security forums like FIRST, recommend to reach out. We have a whole conversation we could have about what parts of AI systems get CVE IDs. And sort of it's a fringe idea, but that is circulated within the computer security community more broadly, that like CVE IDs are a kind of boundary object. The identifier lets you go between the software engineer and the system engineer who actually owns and deploys the system. And it also allows for some communication with the risk manager and the other folks in the organization who are all like involved in this sort of sets of conversations, change management. Everyone brings their own value to what the CVE ID like means to them, but it also is relatively stable across these different boundaries so that people can use it to converse. I think still a bit unresolved as to how exactly maybe CVE policy should be applied to all AI systems. The paper I referenced earlier opens the question as to whether, the gradient descent algorithm has a vulnerability in it, or whether maybe it's a CWE like that, CWE 1039 referenced earlier. One way or another, there's, these weaknesses or vulnerabilities or something in some of the ways that AI systems just have to be built. How do we message that to people so they can appropriately manage the risk? One of the things I often hear is that you can't have a CVE ID if there's no fix for the problem, which just like is not the way that vulnerability management works. There's very often CVE IDs that need to be mitigated rather than remediated. Mitigation in this sense is a jargon term meaning reduce the possible either occurrence or outcome from the exploitation of the vulnerability without removing it. Remediation would mean removing the vulnerability from the system. Also, patching and applying a patch is not the only possible remediation outcome in vulnerability management. You can always discontinue use of the system. Of course, that would be often not acceptable to folks, but of course it is a risk management option if the benefits outweigh the costs to go that way. So certainly can identify things and let people make their own decisions. When we talk about adversary campaigns, there's like almost a whole separate set of jargon, right? So the community in information security came together and identified MITRE ATT&CK techniques, whole vocabulary for the way that people move through networks during adversary campaigns. MITRE and the community has also published their Atlas extension to this, which is a very similar set of ways that people attack ML systems. So in this way, we see sort of a very natural coming together of the communities to talk about things in very similar ways that should allow folks to talk to each other. And I think this is like a really nice example of how AI systems are both similar to other information systems, but also distinct enough that they need some of their own treatment, which is a recurring theme, right? Like just because AI systems are software systems doesn't mean they can be treated exactly the same as all of their software systems, but it does mean that we want to learn from the community for software systems and security of that, and sort of meld it together rather than having folks do totally their own things. The last point, we have a robust secure by design initiative here at CISA, which if you haven't had a chance to look at yet, I do recommend you take a look at. Director Easterly gave a very good speech at Carnegie Mellon University last March to sort of promote the whole secure by design concept, and it's come up in a number of her speeches since. The secure by design work has three broad principles, which is that organizations take responsibility for the security outcomes of their customers. There's radical transparency and accountability to achieve those outcomes, and that the organization takes seriously the organizational dynamics and structures that are necessary to achieve those changes and buy-in at the appropriate management level. So the secure by design document from October 2023 has been co-sealed by, I think, 17, 18 organizations from 14 countries. So very broad sort of international agreement on the secure by design principles from the various security organizations within the various governments. In November, I was very privileged to be at the release for the UK and CISA's guidelines for secure development of AI systems. That one was co-sealed with 18 different national security organizations, including several from the US, so it was actually 23 organizations. So again, very broad sort of international agreement on broad concepts for secure AI system development. Both of these, even though design is sort of forwarded and development is forwarded in the titles, right? You can't have anything be secure by design if you can't issue good patches, issue good updates, make decisions about end of life. Because although, we would love to have something that is totally perfect from development, we know from, very basic computer science concepts, Turing completeness, Rice's theorem, right? That we will not be able to make a general purpose computer that is perfect. There will be vulnerabilities, there will be problems. So very much includes a whole lifecycle approach to, have you conceptualized a useful tool? Have you designed and implemented it according to good practices that are secure by design? Have you prepared for update distribution and vulnerability report intake and these sorts of services that you need to do to support and maintain the software for a defined period of time? And do you have like a specified end of life plan, right? That's like sort of the broad life cycle is all included in secure by design. And AI systems are software systems, and so they also should be secure by design. And so that is our perspective on driving that forward and how we're trying to sort of make sure that these communities have a fruitful intersection and are able to achieve these goals, to make sure that as we all grow to depend more and more on AI software systems, that we can rely on them because they're secure by design and they have perfect interface with the existing, security and risk management community, that sort of thing. That being said, is a great goal, and some examples here for how we're specifically driving towards that. There's a lot more work to be done. Would be happy to hear about anyone's thoughts on how we can help drive these communities to work together better and what we can do to smooth that out. With that, I believe we have maybe 8 minutes for questions. Happy to take any questions. I don't see any in the question and answer sort of box right now. If I'm wrong, someone please speak up.
Well, thank you so much, John. I think that's wonderful. I will ask a first question because I don't see one there. How do we know that you're really a person and not an AI construct?
Well, I mean, if I passed the Turing test as this AI generated image, then does it matter? I mean, do you want to get into like Wittgenstein and like shared language games and that sort of thing? Because we could also do that. That'd be fun.
No, I just, I think it's an interesting question as we think about some of the issues involved. The authenticity aspect of security is too often overlooked. And we're already seeing this with political campaigns, for instance, or political rhetoric about the authenticity of both video and audio. So I just wanted to, bring that out more than just the correctness of models. There's the whole question of trustability and authenticity.
Yeah, and that touches on a broader concept of responsible use, which is centered really in the latest AI executive order, right? Responsible use of AI, both by US actors and sort of ensuring that over like sort of the whole space. Obviously, we want to incentivize responsible use of AI systems and make sure that the US and partner countries can lead in that. And also, you may have seen Director Easterly and Kate Conley had an article in Foreign Affairs about a month ago about specifically sort of the topic you're mentioning here around AI impacts on election cycles and stuff like that. And of course, our election workers, the whole election infrastructure needs to be very robustly supported in order to manage various risks, because people are, trying to undermine US elections. But I also think that those election workers in the American public can be provided with and have the tools to identify those things. This is a continuation of threats that we've seen, right? It's making some things that we know how to deal with more urgent, but I don't think that it's I don't think it's something that we're not prepared to deal with if we take it seriously.
Right, yeah, the continuity of problem sets is one of the things that I think will keep our students engaged and employed for many years to come. Well, it looks like we do have a question posed for you, so I'll let you address that.
I would love to, but I'm afraid that I am not afraid of that specific incident, so I can't speak to it with any competency.
I'm sorry, could you repeat that?
So the question is about some phishing deepfake hack that I'm just not familiar with the details of. So
So to summarize, there was a case at an institution where a financial services person was asked to attend a Zoom meeting, and all the participants in the meeting were deepfakes of company executives, allegedly. I mean, there are some differing interpretations of the story, but the discussion back and forth by these deepfake personas, or personas that were being controlled by people in real time that were being faked as they were presented, ended up with this unfortunate individual authorizing wire transfers that were basically criminal criminal recipients.
okay.
So,
Okay, so I hadn't seen those specific details, but that seems plausible and makes sense, right? From a security operations point of view, I think the answer is to some extent, phishing resistant multi-factor authentication, email authentication protocols like DMARC that prevent spoofing that have been around for quite a long time. I think that people are used to treating verbal authorization as a kind of factor for authentication, to your point about authentication and authorization, like authentication factors, biometrics, voice print, right, have generally been seen as one, but maybe not explicitly. And so maybe people need to make their authorization policies like a little bit more explicit in response to this sort of thing. But I think that we have the tools to do that. We have security tokens that can be used to authenticate that you have to, pretty reliably actually have to have possession of the token. And so maybe we need to adapt a little bit to that. But
looks like so there was somebody put in the chat. Please put it in the Q&A if you would like it addressed by the speaker rather than in the chat. And there you go.
okay. 1 second as I read. So use of guardrails for generative AI with respect to secure by design. If the design is actually secure, then are the guardrails necessary? I think this is a good question because we're talking here about defense in depth always, right? There's various iterations of this metaphor in security education, zero trust, the castle wall metaphor, defense in depth. Since no security protection or no risk management control in general, not just in information security, is going to be 100% effective, it's always good practice to have multiple layers that can help catch things that slip through other layers, and mitigating controls for mitigating risk at various points of control. So, you can mitigate some aspects of generative AI by changing what data it's trained on. Right, if you don't want it to be able to talk about some topic, then if you remove that topic from the training set, then that will make it harder for it to talk about it. I don't know whether it's provable that it makes it impossible for it to talk about it. So you probably also want to put in guardrails. And then in addition to, say, like filtering guardrails on the input and output of the model itself, you probably also want to have additional controls on who's interacting with the system, for mitigating abuse, for maybe mitigating model extraction, right? These sorts of things. And so at least 3 layers there, besides all of the regular, that you want to make sure you have controls in place to make sure that the operating system that the model is running on doesn't get compromised and have things change underneath you. So I think that is a good example of where secure by design is never going to mean that things are 100% fixed, perfect from design, right? That we're always going to need interleaving areas of control, defense in depth, zero trust sorts of things. And I know zero trust has become a bit of a buzzword, but it is meaningful in the sense that you have multiple layers of controls that overlap and interleave. And also, in the secure by design philosophy, you need to be able to fix things. You need to be able to detect problems. So if you only have one layer of defense or one risk control, it's really hard to detect problems with it because you don't have another layer of risk control. So you need multiple layers of risk control so that you can detect problems when they arise and then be able to fix them. I hope that answers the question.
I think that's good. Understanding risk and what's appropriate to put in place versus the expense and effort and user acceptability and so on are all key to having trust in systems, and have to evolve with systems, with time, with threat, with users. And I don't think anybody can give a formulaic answer to any of these things.
No, I'm glad you mentioned user experience and user acceptance. So that's just like yet another whole discipline that has a whole very rich set of like jargon and interests that we have to be able to interface with and support, because if a security control isn't usable and doesn't support the user's interests and the user's goals, then they'll probably circumvent it, right? That's the whole compliance budget set of research. And so we have to be aware of that as security professionals also, in addition to these, domain-specific things about AI or whichever your topic of interest is.
Yes, awareness is not sufficient. You've got to have appropriate motivation as well.
Very true.
So this is great. And I think that exhausts our questions and our time. This has been great to have you speaking with us today, and some good material for food for thought for people. For the attendees of the session today, let me suggest that you look at our schedule. We have one of these talks every Wednesday, and so please tune in for next week. I did notice somebody said, are there resources that you can mention, Jono, that they can quickly learn more?
Well, I mean, I think that is hard because there's so many good resources that you could use to learn more. It depends on which aspect of the problem you want to sort of get into. I do try to have good references in these secure by design things from CISA. CISA.gov has a whole bunch of the stuff that I've referenced here. First.org is the first website, which also is very good for some slightly more academic resources. Right, there's so many diverse good ones, which I don't have all memorized, but I end up writing down when I have done some of my stuff. So some of those things might be useful to mine. And
I think NIST is also.
NIST, of course. NIST has an AI risk management framework, which is separate from their cybersecurity risk management framework. And those two are both good resources. The AI risk management framework is an extension of the NIST risk management framework. NIST has done a lot of good work to make both the risk management framework and the secure software development framework, the SSDF, like a lot more accessible. So both of those NIST resources, very good for pragmatic sort of sets of introduction to controls and risk assessment stuff.
That's great. Well, again, thank you very much. And we'll look forward to seeing some of our audience at next week's talk. Have a wonderful Valentine's Day, everyone. Don't be very careful about clicking on links that say "I love you," unless you really know who the sender is. And have a great evening.
Thank you all.